friends. Today we'll discuss about the UV spectroscopy. We learn basic things in UV spectroscopy. We understand what is the basic concept of the UV spectroscopy. Okay. Let's go to the screen. Uh, Introduction to the UV spectroscopy. UV spectroscopy is a technique. It's an analytical technique used to measure the absorption or transmission of UV and visible light. It is a spectroscopy machine. Spectroscopy machine means it measures the light. That light is maybe ultraviolet and visible light. Okay. The wavelength range when comes to the UV is 200 to 400 nanometer and visible is 400 to 700. Okay. Why UV spectroscopy is needed? There are so many techniques. And what is the specific thing with UV? Olden days, people measures the colors samples like yellow color. They prepare some standards like, for example, it's 1 ppm, is 2 ppm, 3 ppm, 4 ppm, 5 ppm, 6 ppm, 7 ppm, 8 ppm, 9 ppm. They prepared, and to compare the colors, they use the physical method. Physical method means they prepare these standards and they compare with these test tubes physically. If some test tube is matching with this standard, they will let you know this is 1 2 3 4, this 4 ppm, it's content 4 ppm. Like that they measures. This measurement is not accurate. uh, we cannot find in decimal points. For decimal points we need some other instrument, that is UV spectroscopy we need for that. Okay. Here how UV spectroscopy is works. Light passes through the sample. This light passing through the sample. Okay. The detector measures the intensity of the light before and after passing through the sample. For example, the light here, where light source is 100%, 100% light is sending through here. Then after passing through the sample, then it reaches to the detector. After reaches to the detector, how much light observed by the sample, that is we measure here mainly. Okay. Birla's law also says same. Birla's law says what is observance, how it affects. Okay. Observance, there is no units, we simply A is equal to observance we'll write. Okay. Birla's law says observance is directly proportional to the concentration of the solution and light travel path. Is there no? From here and here, light passing, this is travel path in the medium. Okay, you understand, I hope. Here, uh, our range is 400 to 200 to 800, but uh, for different solutions, we sense different wavelength of light. Okay. For this we need different wavelength, right? For that we need to separate the visible light into the different wavelengths, that is by prism. The prism separates the different lights, then the monochromatic split separates the required nanometer light to the sample. Okay. Then detect sample. Instrumentation. When comes to the instrument, light source, for this light source required, light source is there. UV resin. For UV we need deuterium lamp. For visible light we need tension tungsten light or halogen lamp. We need monochromator splits. This split is required for the separation of the separated light. Okay. Sample holder. We need quad while for sample pour. Okay. That is there. Detector. Photomultiplied tube we need as a detector. It is a detector. Okay. Application. As we said, uh, UV does qualitative analysis and quantitative analysis. Quantitative. Qualitative means is the color is any color is present or not, we can identify. Qualitative means how much the color is present in ppm or percentage level, we can identify. Okay. In pharma industry, they do the drug purity. In environmental, they can do water. In water, they can do nitrates, sulfates, and some are they do. Fluoride also they do. Material science. In material science also they will study. The colors also they will study. Advantages. Non-destructive method. The method is more accurate. Uh, how many time we do, we get almost same value. Eye sensitivity and eye accuracy. We can do in decimal points also. After point 0, point 0.01 level also we can do. Application of both qualitative quantitative analysis. Identification and measuring. Limitation. This UV works with only clear solution when sample need to be transparent. Sample which has very high color, we need to dilute it. We cannot do high concentration samples. The observation is more than 2 or 3 like that. Overlapping spectra may be compliant analysis. Sometimes some colors overlaps with another colors, so that is drawback. Limited to compounds that observes UV-VIS range. Some compounds will be not measured in UV spectroscopy. That is one of the drawback. Real world examinations. They said some DNA. We can do the. We can find out the colors, food colors in the given food sample, or we can find out the some nitrate sulfates in the water, and we can identify the some drugs concentrations in the given solutions. Experimental procedure. When we come to the experiment, first we need to select the sample. For example, you want to check some color value of given unknown sample. For that, we need to identify the what is the color. Then you identified, for example, you got KMN for color. Uh, you you have KMN for color. For that, you KMN for, we need to check the suitable solvent. Mostly KMN for dissolves in water or alcohol. Some solvents like fats, some other things may be not dissolves in water. For that we use some other solvents like hexane, or some non-polar compounds we use benzene. Okay. For that we selected your sample dissolving some solvent means, okay, that is suitable solvent for you. Okay. Prepare the standards. You got schema for sample. For that you need to quantify and you know the unknown concentration, we need to prepare standards. Without standard we cannot measure the actual value. Okay, we need to prepare some standard like standard 1 to standard 5, depend on the range. Okay. You prepare standard, then you need the instrument. You switch on the instrument and you stabilize the instrument because it's it's having light source. The light source need to warm up and stabilize. Okay, find out the lambda max. We need to find out the lambda max. Okay, lambda max means which wavelength is suitable for the given sample or given compound. For that, we need to find out the lambda max. Lambda max is nothing but uh, the sample gives uh, good value at some certain nanometer. That nanometer says lambda max, or a sample gives good value or maximum value at a certain nanometer, that is called lambda max. To find out the lambda max, uh, we'll see some images of lambda max how we measure. Uh, we'll see any we get some good image or yeah, this is not good. Okay, we'll try with this. Okay, uh, we take some sample of the KMNO4, which is low concentration or medium concentration sample, and we scan some 200 to 800 scan. uh, we take maximum observance is 1, in below 1 where we are getting maximum peak, that is we select as a lambda max. We can see here, uh, like 400 we got maximum peak here. We cannot consider this is going higher level. Okay, better to take lower concentration then. If it's going higher than one, we'll see this one otherwise. Okay, we can see this. It's yeah, it's some coming at around, okay, 320 like that. Okay, this is thing. Okay, we did scanning, we got some value K-4 lambda max of the K-4. What is K-4? 550 nanometers. We'll see we find any images for K-4 lambda max. Okay, I'm not finding. Okay, leave it. Okay, we find out lambda max. Lambda max, we got which nanometer we need to measure the values. Okay, after that we run the sample blank and we tear to zero. For example, we prepared the K-4 in water, that gives some observance 0.010 for the water observance, but we tell the instrument to the tear that value into zero. Okay, when we tear the water value observance into zero, then we can find out the actual value of the color of KMNO4 value observance. And we tear it to this zero, then we runs the 5 standards. Okay, then we runs the some unknown sample. Okay, that also we note the this observance, standard observance also we notes. Okay, this is the main thing. We go to the Excel, how the instrument calculates the values. For example, water blank here. Water blank you run, you get some observance like 0.010, but you said instrument to tear that value, it's become zero. Okay, then you run standard one, that may gives zero point 0.1. For example, I'm saying how instrument is works. Standard 2, it gives some value like zero point 0.2. Standard 3, it gives some value zero point 0.3. Then standard 4, find 4. Standard 5, find 5. You got some observance. Okay, we write this in another manner. We take same this thing. This is sample, this ABS observance. Okay, we'll write another manner. That is here we'll write this is water. I'm removing it. Okay, this is blank. I'm keeping as a zero concentration. Observance also zero. Standard is 1. Okay, 2, 3 ppm, 4 ppm standard, 5 ppm standard. Okay, this is ppm values. Okay, ppm in concentration, observance, light observance here. Okay, for this we prepare some linearity graph. We click some recommended graphs. Okay, it's given some graph. Okay, data label I'm putting. Okay, we can see this linearity graph is so linear, it's like going like 45 degrees. Okay, for this we find out correlation coefficient. Correlation coefficient means how linear your graph will low by this thing. Okay, you're taking x value, x axis, y axis. We got r square value is 1. When we prepared standard, we did some mistakes, something else there. Instead of 0.2 or 2 ppm, we run 3 ppm standard. We got some 3.3 now. The graph will vary and this value will be effort. Okay, at least this r square value should be 0.995. It's minimum value, but better you go at least 999. Okay, if you do better way, the graph will be comes like this. If you did some mistakes or something else, the graph go very worst, something will happen like that. Okay, then your values vary. This is not acceptable. Okay, so that is keep in mind. You prepare standard while making one means it's very accurate. So you got this. Okay, you run standard and you run some unknown sample. Unknown. Okay, run some unknown. You got select 0.35. You got point 0.4. mm, okay, you got some unknown. We take this one. Okay, we're taking zero point 0.3 unknown sample, 0.35 observance sample. Okay, how instrument calculates the unknown sample? We also can do that with plotting linear graph, like when we are in 10th standard. Same that also we can do. I'll show you how instrument calculates the unknown value. I copied this graph. We go in paint. Mm, I open paint. I'm just pasting the graph. Okay, I pasted the graph. Last time what we got, observance. This is observance. This is standard concentration, 2 ppm, 3 ppm, 5 ppm. Okay, for that we take this line. We got 3.5, right? 3.5 means here. Okay, we line some graph. Okay, line, drawing line. Horizontally we line, it's overlapping here, where they overlapping, and you draw like draw line again vertically. Okay, vertically you draw line. You check here, it's showing between 3 and 4, that is 3.5 ppm, so that we can identify it's 3.5 ppm. We take some another example, 0.22. We take 0.22. Okay, 0.22. There is paint. We're taking 0.22. 0.22 means it's like 20% after. Okay, it's getting like this. Okay, we got here. Okay, it's showing 30-70 like ratio. Maybe it's like 0.22. Concentration is 0.22. Here we got concentration is 3 pp, 3.5, 3.5 ppm. Here we got 2.2 ppm, like that. Zero point 0.4 already we know, zero point 0.4 is there already, it's 4 ppm. Like that we can know the unknown concentration values. Okay, for calculation the unknown value, some formula also there that can also do. This is the main concept. UV spectroscopy, we can identify the unknown sample concentration. This is okay. Okay, I'm closing here. I hope you understand the video. If you have any doubts, you can ask me in the comment box. Thank you so much for the today's session.